In lesson 10, we want to talk about what it means to factor completely. And remember, the word completely is usually a giveaway that it's more than once that we need to factor. And a lot of the times, it ends up being a GCF first. Now, not always, but that's what we're going to work on today. So if we look, 5x squared plus 50x plus 80. When you are told to factor the expression, whether it's completely or not, the first thing you always want to look for is a GCF. These have a GCF of 5. Now it's only 5, not all the terms have an x. So then we end up with 5 parentheses x squared plus 10x plus 16. So now our first factoring was the GCF, and now what we want to look for is we want to just focus on what is left here in our trinomial. And that we want to put into boxes. So x squared and 16. Multiply first number by last number, so what multiplies to 16 and adds to 10? Well, that would be 8 and 2. So 8 times 2 is 16, 8 plus 2 is 10. So we are 8x and 2x. So we GCF our top row, we get an x times x is x squared, x times 8 is 8x, x times 2 is 2x, and 8 times 2 is 16. Now here's where you got to be careful at the end. You have to bring down your GCF, which is the 5, along with your 2 parentheses. So your final answer for the whole problem is 5 parentheses x plus 8, x plus 2. So you want to make sure that you are taking your GCF down with you the whole way, even though it's really not included in the second factoring. If we look at the next one, our GCF is 7. So we get 7 and then 4n squared minus 1. This is the factoring difference of perfect squares we did yesterday. 4n squared is perfect, 1 is perfect, and there's a minus sign in the middle. So 4n squared gives us 2n when we take the square root. Square root of 1 is 1. So 7, 2 parentheses, both start with 2n. Both end with 1. One of them gets a plus, and one of them gets a minus, and there's our final answer for that one. So again, take out the GCF, then do one of our other factorings. Here, 5x cubed minus 125. So here they both, or all the terms have x's. So our GCF here is going to be a 5x. And when we do that, we're left with x squared minus 25. So we're going to look at what's in our parentheses. Same deal as before, x squared is perfect, 25 is perfect, there's a minus sign in the middle. So square root of x squared is x, square root of 25 is 5. We end up with 5x on the outside, and then we're x plus 5 and x minus 5, applying that difference of 2 perfect squares factoring from yesterday. GCF of the one to the right, is 2x. So what are we left with here? We have 2x. We have x squared minus 4x plus 3. So now we're back into our trinomial factoring. So we're going to use our boxes. First times last, so multiplies to be a 3, adds to be negative 4. Got to be careful here with the sign change. That would be negative 3 and negative 1. Negative 3 times negative 1 is a positive 3. Negative 3 plus negative 1 is a negative 4. So we're x squared and 3, and then negative 3x and negative x. GCF that top row, you get an x. X times x is x squared. X times negative 3 is negative 3x. X times negative 1 is negative x. And then negative 1 times negative 3 is 3. So that gives us a final answer of 2x, parentheses x minus 3, parentheses x minus 1. For our last one, 18x squared minus 57x minus 21. The GCF for that one is only a 3. So we're going to end up with slightly bigger numbers here. We have 6x squared minus 19x minus 7. So now we're going to be into our trinomial factoring here. So 6x squared and negative 7. Multiply first by last. So two numbers that multiply to negative 42 and add to a negative 19. Well, that's going to be negative 21 and a positive 2. When we multiply them together, we get a negative 42. When we add them together, we get a negative 19. So negative 21x and positive 2x. GCF, that top row, we can take out a 3x. 3x times 2x is 6x squared. 3x times negative 7 is negative 21x. 2x times 1 is 2x. And then 1 times negative 7 is negative 7. So that is our final answer of GCF of 3 out in front. We are 2x minus 7 and 3x plus 1. For our last one now, whenever we do our factoring, we always like our first term to be positive. So that's why this is going to be one of the rare cases where we're going to take out a negative 3 as our GCF. Now when we do that, we end up with a positive t squared. We end up with plus 5t and minus 6. So notice all the signs change when we do that. And again, the reason is whenever we factor, we want that x squared or t squared term that's out in front. We need that to be positive. So that's why this is one of those rare cases where we're taking out the negative GCF. As we do this, we create our boxes. So first times last, so multiplies to negative 6, adds to 5. That would be positive 6 and negative 1. So 6 times negative 1 is negative 6. 6 plus negative 1 is 5. So we are 6t and negative 1t, or just negative t. GCF top row, you get t. T times t is t squared. T times 6 is 6t. T times negative 1 is negative t, and negative 1 times 6 is negative 6. So our final answer, we have our negative 3 as our GCF out in front. We are t plus 6 and t minus 1. So as you can recap here, GCF factoring completely normally starts with the GCF, and then you end up either into your trinomial factoring or your difference of two perfect squares factoring.